Hello and welcome to another demonstration of AbLead, the Antibody Analysis and Engineering Suite from Ketchum Biotherapeutics Consulting. In this demonstration, I'm going to show you the modification of PI. You only really trust the calculation of PI if it's a full-length sequence, something that you would take forward as a therapeutic. So let's check. I'll click on a low PI molecule and check the sequence. And yes, indeed, this is a full-length sequence. This one doesn't have a signal peptide on it. You could watch the assembler video to see how to add components to sequences, but I don't need the leader sequence to calculate the PI in this case. I showed previously that you can go to the physical properties and calculate the PI. It's right here, 6.63. But if you scroll over, it's also in the grid, and there it is at 6.63. So this is low. It's near human serum pH, and so injecting a molecule with a PI near serum pH is going to cause neutralization, which could lead to particulation, and that should be avoided. And another issue is that if this PI gets close to normal formulation buffers, you would neutralize and particulate in formulation, which would not be optimal. And so I'll show you how to engineer this. I have an engineer PI module. And what this module does is allows you to decide if you want to shift higher, more basic, or lower, more acidic. This is a low PI molecule, so we want to shift it higher. It turns off DE, acidic. You could go to a non-formal charged positive and turn this off, and it would select from just these sets. You could turn off sets by ABHAN nomenclature as you wish, but I'll leave on a full switch in formal charge. This can sometimes impact stability violations, but I'll leave it on for the sake of this demonstration. There has to be a PDB file associated with the entry because it's calculating the solvent exposure surface area of the side chains for every residue in the molecule, in the variable domain in the presence of the full-length molecule. So this cutoff is how much surface area should be exposed on the residues that it will show. 10 square angstroms is approximately association with one water molecule. So we'll calculate the targets. And again, what this is doing is it calculated the surface area of every single residue, and it's showing those that are acidic that have at least that surface area. And here's one that's at 36. So for example, if I were to change this requirement to 40 and recalculate, you see that that CD3 is no longer there. So it's a filter for side chain exposure. So these are side chains that are highly exposed and that are acidic. The tool shows what the Abling probability is for that residue. And a few of these have violations. The tool is saying that it should be mutated to a different residue, but they're also in CDR positions. Now, if I were doing this in reality, I would be doing it with a structure, and I would be looking at core fold, possible antigen interaction, not just CDR regions. But for the sake of this demo, I'll just exclude CDR positions, pretending that that's what would interact with antigen. So we'll just mutate framework positions. And what the tool has done is look to see how many combinations that would be. And it says there are 11 entries selected. That's 2,048 variants that would be calculated in the next phase of this tool. And it's showing you the differentiation to the mutant probability, and it's selected residues that it thinks should be modified to that are the highest Ablang probability that is not an acidic residue. Now, I said earlier that you may not want to do a full change from acidic to basic, but in this case, only one position that I've selected is making that modification. So we'll leave it and see what kind of impact it has. If I change the sequence, all of these residue likelihoods are going to change because they're done in the presence of the whole length sequence. So this is a minor change though, as it stands. It's less than a difference of 1, so it's not so impactful. So I'll keep these as they are and I'll click build combinations. But before I do, there's a combination settings. This is the amount of humanness score loss that I'm willing to accept. And this is a pseudo AbLead loss that I'm willing to accept. Again, once you change the sequence, all of the AbLead scores are going to change. And so a pseudo AbLead score is, if I assume no change in sequence, what would the impact on the stability violation score be? And I'm allowing at most 20 for AbLead framework. And then how many combinations I'll allow the tool to show. So even though it's calculating 2048, it will filter by humanness loss, it will filter by stability loss, and then it'll show the top 100. So let's build those combinations. It takes a moment to do all of those calculations, and there they are. So it's started at a humanness score of 0.767, and you can see that many of them are still within that range, and that's great. It started with an AbLead of 57.46, and you can see we have indeed change that score. Again, it's a pseudo score. We'll see what the calculation is once we actually build these. You can sort if I wanted to see if there were smaller ones, and there are. The 8.21 is the highest PI that was reached. But if I sort by the pseudo AbLead score, you can see I can lower the stability violations, but it doesn't raise the PI as much. Still, it's a fairly acceptable range. And you can sort by humanness as well. So let's make one at 8.07, and I'll sort by PI, and let's make one at 8.21. So I have 2 entries selected. I could export those entries as Excel, or I can build them. I could export this grid as Excel, so you can save it for your notebook, or I could build the FASTA and send those off to be made, or I could build them and populate them back into the main grid. Like many of my tools, I'm one, inherently lazy. I don't want to do this by hand. And two, I know that humans make a lot of errors. I don't want to go do all of these mutations by hand in a text editor. So if I just click build selected, it's going to build those 2 items, run all of the calculations. It's rerunning all of the AbLead scores, all of the PI, everything that's back in the main grid, determining the germline, making sure it didn't change the humanness. I'll return the tool because I can build more if I'd like to, or I'd come over here to the engineering panel. I'll sort by name so we can get these together. There's the low PI and its variance. You can see that it maintained humanness, and there's its nearest neighbor, the stability. We did impact the stability a little bit, but if I'm looking at the framework violations, it's still green. We raised the stability violations, but not so much that I'd be concerned about impact on biophysical characterizations for conformational stability. These do not have PDB files associated with them, so the surface properties were not calculated. That's something that probably should be done since you've changed surface residues in this case. And if I scroll all the way over to the humanness, you can see that it didn't impact the overall humanness score much at all. And it did increase the PI exactly as was predicted. So there's engineering PI. You don't have to throw the molecule away. You can make modifications, test it for efficacy. I would, of course, look at these mutagenesis positions that were made and see where they are and see if I thought they were going to impact efficacy before I made them. But the PI of a molecule can be shifted, and this tool helps to track that. So I hope you've enjoyed this video. Thank you so much.